Hello everyone. In this session, we'll be solving a problem based on characterizing amplifiers. So this is the question. It says a transistor amplifier is fed with a signal source having an open circuit voltage Vsig of 10 millivolts and an internal resistance Rsig of 100 kilo ohm. The voltage Vi at the amplifier input and the output voltage V0 are measured both with and without a load resistance RL, which is equal to 10 kilo ohm, that is connected to the amplifier output. The measured results are as follows. So these are the values of input voltage and the output voltage with RL and without RL. And we are supposed to find out all the amplifier parameters in this question. So what we'll do is, first I'll just brief out what we are going to find out in these type of questions. So first we'll consider that RL is equal to infinite, meaning the values of input and output voltages when RL is not connected, and then we'll find out the value of voltage gain and the total voltage gain, and from after that we'll find out the value of RI. And next I'll consider the values of input and output voltage when RL of 10 kilo ohm is connected, and then again I'll find out the value of voltage gain and total voltage gain, and now I'll find out the value of R0 when RL is connected. And now after this I know GV and GV0 both now. So from this formula I'll calculate R out. Next, I'll calculate R in from this voltage divider rule. After applying this rule, I'll get this particular equation, and by substituting the known values, a known value will be R in alone. So R in will be found out from this equation. And next, we have left to find out the short circuit transconductance, and then current in AI. So in order to determine current gain AI, same step is followed as we follow for output voltage gain, which is equal to output voltage by input voltage. Same current gain is also output current by input current. And next, last thing is we'll have to determine the short circuit current gain, and this is it about this problem. Let us go through how we have solved this. So first, I'll consider input and output voltages without RL. So without RL, if I find out the voltage gain and the total voltage gain, it will be written as AV0 and GV0. So AV0 is equal to V0 by VI. So without RL, VI is 9 and V0 is 90. So I substitute 90 for V0 and 9 for VI, and I'll get AV0 as equal to 10 volt per volt, and GV0 is equal to V0 by V signal, that is given as the input to the circuitry. This V signal data is given in the problem itself as it is equal to 10 millivolt. So V0 without RL is 90 millivolts, and this input voltage Vc is also 10 millivolts. So I'll get GV0 is equal to 9 volt per volt. And now we know that GV0 is equal to Ri by Ri plus R signal into AV0. So now I'll substitute the value of AV0 that I got, and R signal value is given in the problem itself here as it is equal to 100 kilo ohm. So I'll substitute, and here GV0 I got it as equal to 9 volt per volt. So the unknown term in this equation is only Ri. So upon simplification, we will get Ri as equal to 900 kilo ohm. So these are the three parameters that is to be found out when RL is not connected. Now, when RL is connected, we'll find out AV, GV and R naught. So AV is V naught by VI. So when RL is connected with RL connected, see here, V naught and VI, V naught and VI is equal to 70 and 8 millivolts. So V naught by VI is 70 by 8, that is equal to 8.75 volt per volt. And GV is equal to V naught by V signal, that is equal to 70 by V signal is already given in the data as 10 millivolt. So upon simplification, we'll get GV as equal to 7 volt per volt. And now we know that AV is equal to AV naught into RL by RL plus R naught. Now I know AV naught. I had calculated it previously. And now AV, we got it here as 8.75. And RL, it is already given in the data as equal to 10 kilo ohm. So I'll just substitute 10 here. So whatever I get the value of R naught should be in kilo ohm, right? So upon simplification, I'll get R naught is equal to 1.43 kilo ohm. And now we have found out the value of GV and GV naught previously. Okay, so now we know that GV is equal to GV naught into RL by RL plus R naught. Now I'll substitute GV, GV naught and RL, and the only unknown that is remaining in this equation is R out, and this can be simplified, and R naught is found to be 2.86 kilo ohm. And next we need to find out Rin. So by applying voltage divider rule, we will get Vi is equal to Rin into V signal by Rin plus R signal. See here, I'll show you. By applying voltage divider rule here in the input part, we'll get that equation. All right. And now after this, after getting this equation, I'll substitute the value of Vi, Vsig, Rin, sorry, RC here also in the RHS side, and only unknown remaining here is Rin, and this can be found out from by applying the voltage divider rule, and we have found it to be equal to 400 kilo ohm. And next we need to determine the short circuit transconductance. So short circuit transconductance is given by Gm is equal to AV naught by R naught. AV naught, we found out that it is equal to 10 volt per volt, and R naught is also found out here, and it is also equal to 1.43, and upon substitution and simplification, we'll get Gm as equal to 7 milliampere per volt. And next we need to find out the current gain. It is equal to output current by input current, the ratio of output current and input current. So output current is V naught by RL, load resistance we have at the output side, and divided by at the input side, the input current is Vi by Rin. So upon simplification, we will get V naught by Vi into Rin by RL. So this V naught by Vi can be written as AV into Rin by RL. And upon substitution of the values of AV, Rin and RL, we will get the value of current gain as equal to 350 ampere per ampere. And next we need to find out the short circuit current gain, that is AIS. This is equal to IOSC, that is output short circuit current, which is equal to AV naught into VI by R naught. See here, now consider this equivalent circuit A that is shown here. Okay, from this circuit we have written that the output current ISOC is equal to AV naught into VI by R naught. Okay. So now IOSC is equal to AV naught into VI by R naught. So now we know AV naught and we know R naught. We have found out that. But this VI, to find out VI, we need to first find out the value of Rin that is obtained with RL equal to 0. So for that, we need to consider the equivalent circuit C. Go back to the previous set of notes, and previously I showed you equivalent circuit A, isn't it? Below that itself I've written equivalent circuit C. Go back to it and you will come to know how we analyze the equivalent circuit A. In the similar lines, analyze equivalent circuit C and you'll come to know that output short circuit current is equal to GV naught into VSIC by R out. It is very simple. You can understand this and name this as equation 2. And whatever we got the equation for output short circuit current from equation A should be named as equation 1. And since these both are the same, that is output short circuit current, we can equate this. So upon equating, we'll get this equation, and upon substituting for GV naught equal to Ri by Ri plus Rc into AV naught, and Vi as equal to V signal into Rin when RL is equal to 0 by Rin when RL is equal to 0 plus R signal, we will get Rin by Rin for RL equal to 0 as equal to R signal by 1 plus R signal by Ri into R out by R naught minus 1. Upon simplification, you will get this equation. Try to simplify and just substitute and calculate the value of Rn for RL equal to 0, and you will get it as equal to 81.8 kilo ohm. If you have any doubts, you can get it clarified. And we know that output short circuit current is equal to AV naught into VI by R naught. Now this Vi is equal to V is equal to I into R in general, isn't it? So I is equal to II into the R that we are going to consider here is R in, because it is at the input side. So II and R in for RL equal to 0 divided by R naught. Now we got the value for R in when RL is equal to 0 as so much. So I'll substitute 81.8 for this, and R naught is equal to 1.43 and AV naught is equal to 10. So now in ISOC equation, except for this input current II, we know all these three parameters, and the current gain AIS, short circuit current gain, is equal to ISOC, that is the output current, by II, that is the input current. So by using this formula in this equation, the II in numerator and denominator will get cancelled, and the resulting value of short circuit current gain will be equal to 5.72 ampere per ampere. So this is how we are supposed to solve a problem when the amplifier parameters are supposed to be found out. So another two problems will be given as assignment. Try to solve it and submit it. Thank you.